Hello, we are back talking about Chapter 8, Lesson 6, Solving Systems of Linear Equations by Graphing. So let's go ahead and take a look at this one. So we have a fishing boat that leaves the harbor traveling east at 16 knots, which are nautical miles per hour. After it travels 40 nautical miles, a Coast Guard cutter follows the boat, traveling at 26 knots. After how many hours will the Coast Guard cutter catch up with the fishing boat? Okay, so we have two different things. We have a fishing boat. The fishing boat is traveling east at 16 knots, nautical miles per hour. Okay, after it, which is the fishing boat, travels 40 nautical miles. So that actually has something to do with the fishing boat. A Coast Guard cutter follows the boat. I imagine that a Coast Guard cutter is another type of boat, some type of something like that. So we got a Coast Guard cutter, which is probably some type of boating vessel, traveling at 26 knots. Okay, after how many hours will the Coast Guard cutter catch up with the fishing boat? Perfect. So we have two things, fishing boat and a Coast Guard cutter. What are the things that we don't know? Well, what I'm going to say is what we don't know is we do not know, we don't know the time, right? So what we're going to do, we don't know the time when they're both going to be at the same, when they catch up to each other. So what we're going to say is let t equal time, okay? And then the other thing we don't know is we don't know what the distance is going to be when they catch each other. So let t equal time and let d equal distance. All right. So when we're doing a problem like this, we need to set up. This is something where it has two different scenarios. We have the scenario of the fishing boat, and then we have the scenario of the Coast Guard cutter. And when time is 0, where are both of those? So when, if I say when there is no time, right, where is the fishing boat? Well, so the fishing boat at time 0, right? The fishing boat actually has a 40, it says after it travels 40 nautical miles, that's when the Coast Guard cutter starts traveling. So what I'm going to say is time equaling 0 is when the Coast Guard is starting to go on their journey. So when they start to go on their journey, the fishing boat is already 40 miles ahead of them. So it's kind of like they have a 40-mile nautical mile head start. Okay? And so they have a head, and this is where the fishing boat is. And then when the time is 0, the Coast Guard is back here with right here. So we're going to say the Coast Guard is here. Okay? So this is where the time is, and the distance of the Coast Guard, they haven't went anywhere. They're just starting. But the distance of the fishing boat when the time is 0, the fishing boat is actually 40 miles ahead. Okay? Now from that, the fishing boat is going at 16 knots, right, which is kind of like a rate when it says nautical miles per hour, and the Coast Guard is going 26 knots, okay? Now we're kind of ready to write our equations, okay, and we're really going to write them according to our distance. So we're going to say, let's talk about the fishing boat first, okay? So we're going to talk about the fishing boat. Now, the distance of the fishing boat is actually equal. Well, you want to talk about how fast it's going. Well, it's going 16 knots. That's the rate. So it's going to go 16 knots for each hour, which is the time, right? So each hour it's going 16 nautical miles per hour. So 1 hour, it's going to be 16 times 1. 2 hours, 16 times 2, all right? But with this scenario, it has a 40 nautical mile head start. So we're going to add 40 to that. So it has a 40-mile head start, and then from there it's going 16 nautical miles per hour. Okay? In comparison, the Coast Guard cutter their distance, well, they're going 26 knots. So they're actually going faster, but they're just behind. 26 nautical miles per hour. So we times that by time. But they have no head start. Their head start is 0. So plus 0 or just nothing there. So those are really, we have two different equations there. And so how we're going to solve these problems is actually by graphing them. So we're going to graph these two equations on a graph. So we have this graph here. This graph is in its time versus distance, okay? So we're going to graph the first equation, which is of the fishing boat. And if you remember, that equation is, let's see here. That equation is, I want to make sure you can see everything. The distance equals 16t plus 40, okay? And we're going to go ahead and graph that. So remember, this would be our y-intercept, would be 40. Okay, from there, our slope is 16 over 1. So with this, because the slope is 16 over 1, I had to actually make the y-axis, the distance, I had to make it in increments of 2. So this little gray thing, that's 2, 4, 6, 8, 10, and then so on. So we're counting by 2s here, and actually we're just counting by 1, 2, 3, 4 for the time down here. So I actually had to get this extended graph to be able to, graph it all accurately here on this x and y axis. So our y-intercept is 40, so I'm going to go ahead and mark that there. From there, our slope is 16 over 1. That means our rise is 16 over 1. So from 40, I have to go up 16. So 40 to 50, that's 10, and then this would be 2, 4, 6, or this is 10, 12, 14, 16, so right here. And so up 16 over 1 would be right there, okay? Then I have to go up 16 over 1 again. So 2, 4, 6, 8, 10, 12, 14, 16 over 1 would be right there. And then do it again. 2, 4, 6, 8, 10, 12, 14, 16 over 1. And then one more time. 2, 4, 6, 8, 10, 12, 14, 16 over 1. And I think we can get in another one, so let's go for it. 2, 4, 6, 8, 10, 12, 14, 16 over 1. And I think we can get one more. Let's go for it. 2, 4, 6, 8, 10, 12, 14, 16 over 1. And if you see, all of these lovely dots just line up into this really quite beautiful straight line, and they all line up on there. It's kind of cool. Okay, and there we go. And I'm going to actually just go ahead and label this point. I mean, not this point, but this line. This is D equals 16T plus 40. And this is the fishing boat. Fishing boat. Okay, cool. So that is the trajectory of, or the line of the fishing boat. Okay, let's go ahead now and graph what's going on with the Coast Guard, which is D equals 26 T. Oh, that's not 26, 26 T. Okay, and that is where the y-intercept is 0, which means that this is a direct variation, which is nice. And then the slope is actually equal to 26 over 1. Perfect. So, because this is like our x, the t is like our x, and the d is like our y. This is like our x, and this is our y. So the slope is always the number in front of the x. Okay, so we're going to graph it. Our y-intercept is 0, so right there. And then we're going to go 26 over 1. So 20 is up here, 10, 20, then 22, 24, 26, right there over 1. Okay. And then we have to go 26 over 1. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 over 1. And I just want to make sure that that's right. So, yeah, 2, 4, that would be 14, 24, 26. Perfect. All right. And then we're going to do it again. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 over 1 right there. Let me just count that. So that would be 2, 4, 6, 8. That would be 18, 20, 22, 24, 26. Okay, cool. And then from here, we're going to do it again. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 over 1. And look at there, right on that point. That is our point of intersection. That's the solution to our equation. Woohoo, awesome. Let's go ahead and graph this. Okay. So exciting. Okay, look at how nice they all line up. Very, very nice. Very, very nice. Okay. So right there. Okay, so this is our, I'm going to label this line. D equals 26T, and this is the, what is this? This is the Coast Guard cutter. Coast Guard cutter. Gonna label our lines. And notice how we labeled the X and the Y axes and the units, hours, and nautical miles. Okay, but this right here, this is our solution. So we have to count that up. So our solution is, the time is 1, 2, 3, 4. So that means X is 4, or I mean T is 4. And then our distance is actually 100. This is 100, 102. It looks like 104. 104. Okay, that's 104 nautical miles. That's our solution. So that's how you find your solution, by graphing. Perfect. Okay, but what we're going to do is we're going to check to see if we got this right. Okay, perfect. Let's go back to our original problem here. Okay, and what we're going to do is we just solved it graphically. We found that our solution was 104, where this is our time and this is our distance. Okay, and what we're going to do is we're going to solve this algebraically to check, to make sure it's right. All right. So to do that, we have our two equations. D equals 16t plus 40, and D equals 26t. And since they are both equal to D, they're equal to the same thing, what we can say is that they're equal to each other. So we can say 16t plus 40 equals 26t. From here, we just solve for t. Okay, so I'm going to, I noticed that there's variables on both sides. This one's smaller, I'm going to move it. It's positive, so I'm going to do the inverse operation, which would be negative 16t. to both sides. That cancels. I'm left